As I promised, I will work this week 3 recitation work. Let's see the first question. So we want to graph. We want to graph those functions. And each one of this will be a reference graph for later on. Later on, we'll see the similar graphs are transformations of those basic graphs. So the first function we call identity function. Identity function. So the graph looks like this. The graph cuts the first quadrant and the third quadrant into half. So let's see, this is our coordinates. On the graph, let me change my color to be red. So the graph cuts the first quadrant and the third quadrant into half and passes through the origin. So that's the graph, right? And of course, we indicate it with arrows, which means this direction goes on forever, and this direction goes on forever. So this is the identity function. Why it's called identity function? Because we input is x, output is x. So it doesn't change anything, right? Input x, output x, which means on the graph means every x value equals to y value. Right? So here, all the points on this line, x value and y value are the same. Then we can think of all other linear functions are transformations of this function, this identity function. Let's see B. B, I'm going to graph on the same one with green color. Absolute value function. Right? Absolute value function is a V shape. So I have this branch. Then we have this branch. It's a V. And of course, we indicate with an arrow. So, oops. It keeps going this direction forever. It keeps going on this direction forever. So we have this V shape. That's the absolute value function. C is a quadratic function. So let me graph with purple color. So it's roundish. So this quadratic function. So this purple color. The square root function. Oh, let me erase. Let me just make another graph. Right, that's our coordinates. Let me graph with blue color. So the domain of this function is x greater than or equal to 0. So x starts from 0. Looks like this. So the origin is the starting point. The graph goes this way. Right. So the shape goes this way. Or if we want, we can mark a couple points. Right. If x equals 1, square root of 1 equals 1. So this is 1 also. If x is 4, let's see 4 maybe somewhere here. X, square root of 4 is 2. So the y value will be 2. So I have a point somewhere here. Then x cube, let me grab with red color. X cube goes through the first quadrant and the third quadrant. It wiggles at the third quadrant. Or we could see it's symmetric with the origin. So this is the x cube. Right? If we want, we can also graph a couple points. Cubic root of x. Cubic root of x, a little bit similar to square root of x. but the domain is everything. So let me use a green color to graph. So cubic root looks like this. It's also roundish. And then on the third quadrant also. On the third quadrant also. You can always give a couple points, right? You can give 1 or 0, 0 origin is on the graph. And the cubic root of 1, still 1. Then you can think about cubic root of 8 equals to 2, right? Cubic root of 8 equals to 2 somewhere here. Maybe cubic root of, maybe A is here. Then cubic root of A is 2. You have these points on the graph. So those are the basic graphs. Now, when I work on this, you know what? I think I have done all those questions already. But anyway, let me finish them. So the next one is graph this piecewise function. So let's graph the coordinates first. So I have these coordinates. Then the first one, the first piece is this, x less than -3, right? Let's see if this is -3. X less than -3, starting from -3, so the function is constant function 2. Let's say this is 2. So I have this point. So I have this piece. I have this piece. This graph. So this is the first piece. The second piece goes from -3 up to 1. -3 up to 1. 1 maybe somewhere here. And is this quadratic function? Quadratic function. So x starts with -3. -3 squared is 9. 9 plus 1 is 10. Let's say 10 is somewhere here. So I have this point. Then it's a quadratic. So like this. The y-intercept is 0, 1. Then up to 1, but not including 1. So we open. So at 1, we have 1 square, which is 1 plus 1, which is 2. But we make an open circle because 1 is not in the domain. So we have this piece, second piece. Third piece is from 1 or more. Right? From 1 goes up to past infinity. So that's the identity function. Identity function is this. It keeps going on forever. Oh, hold on. It doesn't start from this. It starts from 1, 1. Right? Starts from this. So let me see if I can erase this. I should be, oh yes, I can erase that. So starts from 1, 1 with a solid dot and cuts the first quadrant into half. And we indicate with an arrow. So 3 pieces, that's why it's called piecewise function. Let's see 4. Sketch a possible graph of a quadratic function which has 2 complex roots. A graph that opens downwards. And a y-intercept is this, all right? So that's not difficult to graph, indicated with an arrow. Or 0, -2, let's see -2 is here. So this is on the graph. It says open downwards, quadratic open downwards, like this. It has no real roots. It only has 2 complex roots. That means the graph never intersect with the x-axis. It goes away from x-axis. That's it. So this is just one of it. 5, sketch a possible quadratic function that has 2 real roots, 1 positive and 1 negative. So it doesn't matter where. A graph that opens upwards. Well, let's use Blue color, y-intercept is 0, -4. Okay, so that's 0, -2. So 0, -4 might be somewhere here. Open upwards with 1 positive roots, 1 negative roots. Right, this could be one of it. Right, it's just, sketch just one possible one. 6, sketch a possible graph quadratic function which determinant is 0 and its graph opens downward. When the determinant is 0, it touches x-axis. So, and opens downwards means this. I can draw one like this. Because when determinant is 0, I only have one root, one real root, which means the graph touches x-axis at one point. So we have more, 6. And that's it. That's all 6 questions for recitation worksheet 3. Okay.